El Niño is everywhere in the news right now, but the way people talk about it, you'd think it's something Michael Bay cooked up. The season of death and destruction. El Niño may eat the blob. The Bruce Lee of El Niños. No, the Godzilla of El Niños. Wow, that escalated quickly. Okay, let's all take a chill pill and see what this El Niño thing is really all about. El Niño is, of course, Spanish for the Niño. A few centuries ago, fishermen in Peru noticed every so often the water in the eastern Pacific would get warmer. It didn't happen every year, but when it did, it always happened close to Christmas. So they named the phenomenon for the Christ child, or El Niño. To understand how El Niño works, think of the Pacific Ocean like a giant bathtub. Thanks to Earth's rotation and the Coriolis effect, winds near the equator usually blow east to west. Just like when you blow across a cup of tea, that wind actually pushes the water, so much so that the sea level in Indonesia is usually a ½ meter higher than in Peru. As that water near the surface, warmed by the sun, is forced west, it causes deep, cold water to rise in the east to replace it. That means warm over here and cold over here. If those east-west winds blow harder, warm water is pushed way west and the eastern Pacific gets even colder. We call this La Niña. But if those east-west winds weaken, there's less cold upwelling and that huge mass of warm water ends up sitting just off the coast of South America. That's El Niño. El Niño can hold a ton of energy. The 1997 El Niño moved 35 million billion joules of energy into the eastern Pacific, as much as 160,000 SAR bombas, 100 times the energy used by everyone on Earth in a year, 1/14 as much as the meteor impact that killed the dinosaurs. That's a lot, and when that energy gets transferred to the atmosphere where weather happens, it can have effects that reach around the world. The El Niño during the Northern Hemisphere winter of 97 and 98 was the strongest ever on record. Rain and mudslides in California and Peru killed dozens and left thousands homeless. Kenya's annual rainfall was 40 inches above normal. And on the other side of the Pacific, Indonesia had massive droughts. Temperatures in Mongolia hit 108 degrees Fahrenheit. And while El Niño usually means a quieter Atlantic hurricane season, it can mean more and stronger storms in the Pacific. In 1997, Hurricane Pauline dumped 27 inches of rain on western Mexico in a single day. With so much money and life at stake, it would be nice to be able to predict El Niños, or is it Los Niños? Well, and their effects far in advance. Will California finally get some rain? Will the Northeast get less snow? Well, we just don't know. For one thing, an El Niño event can show up anywhere from every 2 to 7 years, or sometimes not at all. It's less of a cycle and more of a periodic, sometimes quasi-cycle. Yes, that's a technical term. Now I know it's easy to joke that weathermen don't always know what they're talking about.
Ron, where's my legs?
Truth is, for systems like El Niño, prediction isn't just hard, it might be impossible. One day in 1961, meteorologist Edward Lorenz was running some mathematical weather simulations on his computer. He needed to repeat one he'd done earlier, so he re-entered his variables by hand and pressed start. Only when he looked at the results, they were completely different than the first time. Lorenz was baffled and he checked his work. He realized that he had accidentally rounded one of his variables. Instead of 0.506127, he had left off the last 3 decimal places. This tiny difference, just a few 10,000ths of a unit, had completely changed the result. This accident gave birth to chaos theory.
Still not clear on chaos.
It simply deals with predictability in complex systems.
Lorenz had stumbled across the answer for why no matter how advanced our computers or models may get, we can never accurately predict the weather more than a few days out. In any system, the tiniest change in initial conditions could lead to completely different outcomes. And the farther out you try to look, the more those tiny uncertainties are amplified. It was this realization that led Lorenz to ask his now famous question: does the flap of a butterfly's wings in Brazil set off a tornado in Texas? That so-called butterfly effect doesn't mean that butterflies are literally causing tornadoes or El Niño. only that the tiniest change can have a huge impact down the line. This simulation tracks the movements of a particle according to 3 simple equations. The equations, or the rules, never change, but we can see that if we alter the initial condition just the tiniest bit, over time we end up with 2 very different paths. Our atmosphere is just about as complex a thing as you can imagine. An enormous fluid made up of countless individual particles, each of them depending on variables like sunshine, temperature, atmospheric pressure, wind, humidity. All of those particles obey the laws of physics though, and we have equations to describe those laws and huge powerful computers to put it all together. The thing is, even if we were able to measure what every particle in the atmosphere was doing at any moment, for every measurement, there's still that tiniest built-in uncertainty. And Lorenz's chaos theory tells us that this uncertainty, once we go out a few days, even a week, is amplified into no more than a lucky guess. So don't blame the weatherman. Uncertainty is simply built into our world, our universe, and that's okay. We may be able to predict what the weather's gonna be like tomorrow, but as for El Niño, all I know is it's gonna be chaos. Stay curious. That noise marks our daily return from the mysterious world that we call sleep. We spend 1/3 of our lives asleep, yet other than the odd snapshot of a dream here and there, most of us have no idea what happens after we close our eyes.